In example 1, we will graph this exponential function 4 raised to the x power. We will plot 5 points on the graph of the function and also draw asymptote. Find the domain and range. So remember, for exponential functions, we have a horizontal asymptote at y equals 0. And this is before any kind of vertical transformation. So if we move it up or move it down, we will have a different horizontal asymptote. Like for example, if you have a regular y equals 2 to the x power, we have a horizontal asymptote at y equals 0. Okay? But if you have y equals 2 raised to the x power, and say that you subtracted 3. So what will that do? That minus 3 will shift the graph down 3 units, right? So the horizontal asymptote will shift down to y equals negative 3. So it depends on the vertical translation. One more. What if you have y equals 2 to the x power plus 7? Well, then because the graph got shifted up 7 units, we have a horizontal asymptote at y equals 7. So remember that. So if there's no vertical translation, no number being added or no number being subtracted outside this exponential term, then the graph will automatically have a horizontal asymptote at y equals 0. And I think that is the case for the example that we're about to graph. We have y equals f of x equals 4 raised to the x power. Because we don't have plus 3 or minus 7, we have nothing attached to this. So what we will have is we will have a horizontal asymptote of y equals 0, which is just the x-axis. So what you will do is on this graph, go ahead and sketch a dotted line. Go ahead and sketch a dotted line on the x-axis, okay? Oh, my line is not so straight. Oh, I think there's a way for me to do a dotted line. Give me 1 second. Let me try that real quick. So here is a a horizontal asymptote on the y-axis, on the x-axis. Okay, here we got it. So this is the horizontal asymptote. Oh, let me zoom in. This is the horizontal asymptote of y equals 0. Okay, so either the left end behavior or the right end behavior will be approaching this line. We'll get infinitely close to this line. So we'll see what this looks like. Okay, all right, maybe I don't need to write this twice. I'll get rid of this, delete. Okay, so we need to plot 5 points. So what I will do is I will go ahead and create XY table, okay? So XY table for f of x equals 4 to the x power. It's always nice to have some positive and some negatives. So what I will do is I will create 0, 1, and 2, and I will also do -1 and -2. I will evaluate these function values. Well, maybe I'll start with the one all the way in the bottom. What is, well, y value is just 4 raised to whatever this x is, right? So y is going to be 4 to the second power because x is 2 this time, right? So if you evaluate 4 squared, isn't that 16? All right, next one. What about 4 to the first power? 4 to the first power is just 4. What about, whoopsies. What about 4 to the 0th power? 4 to the 0th power is 1. And maybe another important note here. I'll say anything to the 0 power is always 1. It's not 0. Remember, anything to the 0 power is always going to be 1. Why? Well, we can talk about that in another video. But 4 to the 0, and you know this step right here, you guys can do this on your scientific calculator if you want to. Next one, I'll do 4 to the negative first power. That is 1 over 4. And 4 to the negative second power is 1 over 16. So I will need to plot these. I will need to plot these 5 points. Now we're going to plot these 5 points. And you know, when you are plotting these points, some of these are very nice points, some of these are very bad. So hold on a second. Let me do the ones that I can first. I will plot, you know what, let me write down what I'm plotting. I'm going to plot, hold on, 2, 16, 1, 4, 0, 1. See, these were nice points, weren't they? Okay, they were the nicer points. Let me see if I can move this a little bit to the side. And then we have some bad ones like negative 1, 1/4. Negative 1, 1/4. And then the last one was negative 2, 1 over 16. Okay. I don't know if you noticed this pattern here. I do want you to see the pattern here. Look at the y coordinates for me. Starting from 16, I do want to say why the horizontal asymptote is true. If you look at the y values, for example, starting with 16, you divide it by 4 to get 4, right? And then 4 divided by 4 is 1. 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. So what's happening is this. Y values are, as you get to the negative side, you keep on dividing by 4. You see that pattern, right? Imagine keep on dividing by 4, okay? Start by $1 million, let's say. You keep on dividing it by 4. But if you keep on dividing, will we ever have a negative value? And the answer is no, right? I mean, this will get so small. Eventually, it's going to be almost 0. But it will never really be equal to 0. You see what I mean? We're dividing 1 by, later on it's going to be a very big number. So that's why we're saying we're going to approach the horizontal asymptote of y equals 0. The y value is approaching 0 to the left of this graph. And it will look more easy. It will make more sense when we actually graph it. So give me 1 second. Let me plot these points. But I just wanted to try to explain why we have a horizontal asymptote of y equals 0. Because as you can see, the y values are getting smaller and smaller, but it's not getting to a negative number. It's actually getting really close to 0. So let me plot these points. 2, 16 first. 2 to the right, 16. Next one is 1, 4. And you do not have to plot these points. These were just my choices. 0, 1. And then the next one was the fraction value. 1/4 is about 0.25. So I'll just try to plot something like over here. And then the last one is 1 over 16. Let me see if I can get a decimal approximation of that real quick, okay? So I got my little calculator up here. And I'm going to divide. Where did that go? Oh, I have to probably move my iPad down a bit. So if I do 1 divided by 16, it's almost 0. So I'll just try to plot a point really, really close to 0. But I know on Alex, you guys will be able to plot any of these values. Oh my goodness. Sorry, my daughter is keep touching my iPad here. So let me just try to plot something very close to 0. And you know what? That is enough for me. I have 5 points. I will go ahead and sketch a curve that is increasing exponentially to the right end, right? But to the left is coming down like a slide. But what's going to happen is it's going to get infinitely close to that red dotted line of y equals 0. But as you can see, dividing something by 4 over and over will not make it 0 or a negative value. So that's why we will have this horizontal asymptote at y equals 0 because the left tail, the left end behavior of this function is approaching y equals 0. Now let's talk about the domain and range of this function, okay? So first of all, domain. Remember, domain of any exponential function is always going to be all real. So let me box that information right here for you. Domain is set of all real numbers, negative infinity to positive infinity. But range is going to be, if it's not translated vertically, range is going to be from 0 to positive infinity. So it's going to be true for this function. And we can also see that from this graph, how the graph does not go below the x-axis, right? So the smallest y value that is actually approaching is 0. So let me just write the domain and range next to this picture here, okay? So the domain is from negative infinity to positive infinity. The range is from 0 to positive infinity. Because it's never touching 0, I am using a parenthesis. I'm not using a square bracket because it's approaching 0, but it's not touching 0. So that is it for example number 1, graphing. I will stop this video and then I will record another one going over an exponential decay function. Now listen, you notice how this purple graph was going up from left to right, right? So I want you to add maybe just one more thing. Okay, if a graph is going up from left to right, this is an exponential growth function because this is going up from left to right. Another example that I will graph with you, that will be an exponential decay, and we will see in that graph, the graph will be going down from left to right.